Hello everybody! Today we will be explaining how to solve an absolute value equation. We'll start off by just explaining what is an absolute value, and then we'll dive into some examples and just procedures practicing how to use the absolute value operation. In the top right corner, we see that we have the definition of the absolute value operation. It says, an absolute value is a grouping operation that outputs each number's distance from zero. It's always positive since distance cannot be negative. And so we can imagine that if we have any number, and I'm trying to see how far that number is from zero. Of course, distance can never be negative. Imagine, for instance, that I'm walking to my local grocery store. I have to walk maybe half a mile there. I get to the grocery store, I turn around to come home, and now I'm walking the opposite direction, but I'm walking the same exact distance. I'm still walking 1/2 a mile. In most situations in math in which I flip something around, it may change from positive to negative or vice versa. But when we're talking about distance, it doesn't matter whether I'm going one way or the opposite way. It will always be positive, something that we've always noticed. An absolute value uses the symbol that looks like these double bars. We've hopefully seen these before. It represents a grouping symbol, and what I mean by that is that it kind of works the same way that a set of parentheses would work, except it does a little bit more than a parenthesis. We know that it's an operation that takes what's inside of it and outputs its positive counterpart. And so let's just imagine GEMDAS and how this is relevant, because this is just yet another operation, just like addition or division or something like that. We're dealing with a group. When we think of G in GEMDAS, we think of groups. Some people immediately think of parentheses, and that is a group, they're correct, but we have other types of groups. We may have absolute values, we may have parentheses like we said, we may have brackets, and so on and so on. There's different ways to group things in mathematics. But regardless, we see that we would approach the absolute value operation in any equation or expression the same way we would approach the parentheses with the extra step. All to say that we would approach the absolute value in any algebraic equation or expression in the same order that we would approach the parenthesis. So it's a group and it's going to come first before the exponent and multiplication and all of the operations below it. Yeah. So let's just practice using this operation. Hopefully most of us are familiar with using this before. Let's say, for instance, I want to find the absolute value of the number 2. Well, if I know the absolute value is an operation that just measures a number's distance from 0, well, let's go to this number line down here and see how far is 2 from 0. So I see 2 is located right here. I want to know how far it is from 0. I go all the way to 0. And I see that that is 2 units. I know that 2 is 2 units from 0, which makes sense. So the absolute value of 2 is equal to 2 because it's 2 units from 0. But what if I want to find the absolute value of -2? Well, the absolute value of -2, let's see how far -2 is from 0. So here's -2. 0 is over here in the right direction this time. And I see I have to go 2 units. And so what does that tell me is that -2 is also 2 units away from 0, which tells us that the absolute value of -2 is also equal to 2. And so it's interesting. We see that 2 separate numbers can output the same absolute value. And that's only because an absolute value could have a negative or positive output. And regardless, it'll always output a positive value. So let's go explore a couple examples. Let's say that I wanted to solve these absolute value equations that we have here. The first equation says the absolute value of x is equal to 5. We don't have to take this step normally to solve this equation, but I'm going to take it upon myself to just imagine what this graph would look like, because it's just another way to help us identify what we're really working with. So if I were to graph the function, the absolute value of x, it would look exactly like this. Labeling my axes, let's say I have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. I probably should have labeled these beforehand. But point being, what are we trying to see is that if I wanted to find a point on this function, so this function has the equation y equals the absolute value of x. If I wanted to know where the absolute value of x is equal to 5, like this equation says here, well, that's just me asking, where is this blue graph equal to 5? And I see that happens there. At this point, this function has a y value equal to 5. But does it happen anywhere else? It does. If I go to the left, at this point, the function also has a y value that's equal to 5. And so we see that there's two separate y values. We have positive 5 and negative 5 that I'm able to plug into this absolute value equation, and both times will output the number 5. And so I have to keep in mind that when I'm solving an absolute value equation, that same property takes place. I need to consider that when I'm solving for a variable inside of an absolute value, the inside of the absolute value operation, it might have gone in positive, it might have gone in negative. We don't know, and so we have to consider both, of course. And so let's now walk through the steps that we would use to solve this and every other absolute value equation out there. So I like to say that we first consider the negative version of the equation. So like we said, this group here, it might have taken in something positive, but it might have taken in something negative. Let's first consider that the thing they took in was negative. So I'll say we have a negative group now instead of a positive group, instead of a positive absolute value, just negative x equals 5. That's the negative version of our equation. We can also say another thing. We can say, okay, well, it might have been positive, whatever went inside of that group. And so I'm going to say that the positive x is also equal to 5. And so we got two different versions of this equation. I like to think of this one as the positive version and the negative version. We just transformed an absolute value equation into two basic linear equations that are pretty straightforward to solve. As we notice, this equation already solved itself. It just says x is equal to 5. That's nice. This equation, we do have to get x by itself. It says negative x. Let me rewrite it a little neater. It says negative x is equal to 5. I need to get rid of that negative, and the easiest way to do that is dividing it out. So I'm going to divide both sides by -1, and poof, it's gone. Now on the left side of the equal sign, all I have left is that x value. On the right side, I have 5 divided by -1, which is of course -5. So I got my two solutions, my two values that might have possibly gone into this absolute value operation to output the number 5. We see that I could have put a -5 in to output the number 5, but I also could have put a +5 in to output the number 5. Either way, they have the same output. And so the solutions to this absolute value equation would be x is equal to negative or +5. But I don't like writing things twice, so I'm going to encapsulate it in this little symbol here, saying plus or -5, which means I'm taking the positive and the negative version of the number 5. So that's the approach we use when solving any type of absolute value equation out there. Let's apply that same technique to this equation over here. So again, we have to keep in mind this group here, whatever went inside of that absolute value bars, it might have been positive, it might have been negative, and so that's going to give us two scenarios. One scenario says whatever is inside of that group is negative, so that group was a negative group. I'm writing the whole rest of the equation, just putting parentheses and a negative in front of it, and I call that my negative version of my equation. And then we have the positive version of my equation. Let me make a little more room. The positive version is just as is. I don't need to put a negative or anything in front of it. That's the positive version. And we see we broke it into two separate equations that just can be individually solved. They both look pretty straightforward to solve. I see for this equation, I should probably start by distributing this negative into the m and the negative into the -2, and we can easily do that. So negative times m is of course just negative m. And negative times -2 is of course just +2. So we have negative m plus 2 on the left side and just that 4 on the right side. It hasn't changed, so it stays the same. I'm still trying to get m by itself on the left side of the equal sign though, and I see that I need to get rid of that 2, and I need to get rid of that negative. Of course, we'll get rid of the 2 first. I see that the 2 is adding, so how will we undo that? We will subtract. If I do it to one side, of course, I'll do it to the other side. And boom, the 2's are gone. What's all that's left on that left side of the equal sign is that negative m. We have our equal sign, and on the right side, we have 4 minus 2, which happens to equal 2. We almost have m by itself, but we just need to get rid of this negative right here. I'm going to do that by dividing out -1 like we did in that previous problem. I divide that -1 out, and all we have left on the left side is now just a regular old m, exactly what we wanted. On the right side, we have whatever 2 divided by -1 is, and of course that's -2. So we have our first solution from our negative version of our equation, but we need to solve this version of the equation, the positive one. This one's pretty straightforward. The only thing I need to do to get m by itself is remove that -2. I know it's minusing, so I'm going to go and add it. If I do it to one side, I'm going to do it to the other. It's gone. It's no longer on the left side, and all we have left on the left side is now just that m, exactly what we wanted. On the right side, we have 4 plus 2, which is 6. And so we see that we got m by itself. We got 2 separate solutions. For this absolute value equation, we know that m can either equal -2 or it can equal 6. Both of those values can be plugged in here to make the absolute value on the left side equal to the number 4.